So for data analysis, there's quite a few tools that are very popular, meaning that in most companies that you will work for, you will find these tools increasingly. So on my screen, I have Tableau, I have Alteryx, I have SQL, then I have Python. The truth about all of this is that in the industry, you could be a tool expert, where there's people that just know how to use Tableau, don't know about Python, and it doesn't matter. They make a decent living. The same goes for any other of the tools. But the later part of my career, I started to really kind of go for more conceptual knowledge. Now, so with conceptual knowledge, for instance, meaning I know how to analyze data, it means the tools don't matter. And I've also worked in, meaning you could give me a tool I've never seen before and just tell me that, oh, this tool does data visualization, or this is a data engineering tool. And when I get there, I'm going to find out that the concepts are the same. So I just go in there and all I'm doing at that point in time is that in this tool, how do I bring two tables together? In this tool, how do I join? How do I union? So that knowledge is really very little, and I can hit the ground running very fast. And that's the reason why I'm putting all of these tools into this course. Please don't be intimidated. I'm just leading with the fact that I don't think you should go deep into tools. What I'm trying to introduce is that you should be more into concepts of whatever you're learning. It just makes you more flexible. So Tableau is pretty much the most popular data visualization tool you find. It's very interesting because I have done Tableau admin work for quite a few corporations as well. And I'm saying that to let you know that this tool costs corporations millions of dollars. Like one particular corporation I left in 2016, I was admin. And as at when I left, we had spent over $6 million procuring Tableau license for the enterprise. And that number was growing every month. I mean, if it was cheaper, they would probably have replaced Microsoft Excel, because Excel is literally the most popular business software in the world. And it's the software that has been used for ages to analyze data and so many things in the organization. And as a Tableau developer, those are the type of jobs you get. A company is bringing you in because there's a function or a department that has all these things they've built, their processes all around some very complex Microsoft Excel, and they come and tell you to bring this into Tableau for them. A lot of the work you get in data analysis is like that. Today, I'll make this more introductory. So Alteryx is a data engineering, I'll call it light data engineering. A lot of companies are beginning to deploy this tool too now. Tableau and Alteryx, I think even when they started, I've been using Tableau for 10 plus years now. Tableau literally would always recommend Alteryx when they started. And now they've built a tool that does what Alteryx does. Tableau's tool is called, I think, Tableau Prep. But what Alteryx does is kind of like you have a personal car, you can drive your car to the grocery station, to the grocery store, gas station, and all those kind of things. But if you bought a new house and you had to move from one house to the other, yes, you could use your car, but your car will probably take 1,000 trips to move everything you own. But you could also go to U-Haul, get a big truck, and move your things in maybe 2 trips. That's exactly what Alteryx is compared to Tableau. There's heavy lifting that Tableau can do. It's not recommended, but Tableau is very good for ad hoc analysis. The CEO of the company can just come down, or somebody in leadership of the company can come down and say, hey, what's going on? We are making profits. We're doing very well with sales. Sales are going up. Our products are doing well in the market, but our costs are also high. These are the kind of things that we get. Can you guys look into what is going on? What is driving this cost? Why is it so high? So that they can figure out what to do. And that's typically the type of work that will come for someone that understands data. And then we go in and we're digging in to all the company's data until we find out what is actually going on. So there's some heavy lifting, all of this we'll discuss, that is better done in Alteryx than in Tableau, even though Tableau can do it just like the same way you can move houses with your personal car, but it would be better done with like a U-Haul truck. So that's what Alteryx is. SQL is a programming language that deals with data retrieval, data storage. It's very old, it's 40, 50 years old. It's guaranteed. You'll find this in 99% of companies, maybe very new companies that are starting up today. Maybe they might be able to escape it. There's a lot of new technology you can build your technology stack on. But I can guarantee you, I don't think I've worked in a company that does not use SQL. I have worked with a lot of, I mean, I train, so I've worked with a lot of people that have gotten into the industry, and many of them have successful careers without understanding SQL. But I would recommend, because if you understand SQL, you have more breadth. When you start to interview, you could talk about the fact that you understand SQL, even if it's very light. You can talk about the fact that you understand all tricks, basically that you're very versatile and you can work with multiple tools. But again, I'm saying I know people that, for example, know only how to use Tableau. They don't know all tricks, they don't know SQL, and they have a good career. So it just depends on the kind of person you are. If you want to get more breadth, I would recommend you take up these tools as well. Python might be very intimidating. I mean, most of the applications that you're using, for example, I think Instagram was built on Python programming language. I'm using that to show the scale of what Python can do. But Python is still also something you can use and manipulate and do very simple analysis. I think the difference between something like Python and Tableau is that with Python, you're kind of like a blacksmith, where if there's anything you need, you can make it yourself. But think about it, somebody or a group of people have come together and used their programming language to build Tableau. And then we go and use Tableau that other people have built. But what has happened very many times as I've become more senior is that tool anybody has built, any software application has limitations, either purposely or whatever the opposite of purposely is, designed into it. And when things like that happen, you have to fall back to something like Python. Python is very good to stitch. So when we hit the capabilities of Tableau, Tableau is not designed to do X, Y, Z, but the business is asking us to do this thing. What do? We bring Python. We build something little, add it to Tableau, and then we can do more. You don't need to understand what I just said to get in the industry, but it's a nice to have skill. For example, if I'm interviewing today, I can talk about all of these things and more, and it just makes me more valuable. The more of these things I've learned, my interviews are almost a one of one, meaning if I had 2 or 3 interviews lined up, I'm probably going to get 2, if not 3 offers. But there was a time I would have to do 20 interviews to get 1 position. But there was a time you even do 40 and you will not get. And right now I know the market is a little bit, it's on the slow side. It's not like previous years. So yeah, that's a brief introduction of the software that I'll be discussing during this course. There's many more. Feel free to ask about it. Like I said, even if you brought a software that I don't use or I'm not familiar with, in a very short time, I can make the software do what I need it to do. And I think that's a very important skill that I think you should learn. Few objectives that I think are key at the end of this course. The key concepts: data analytics, the analytics process. Data types are key and their importance as we start to manipulate data. This is a very key thing that gets people into trouble. Let me talk a little bit about that. Sometimes I have to go and fix what other people have built, or sometimes, somebody's built an application in Tableau. It's worked for 9 months, sometimes it's worked for 1.5 years, and something happens and it suddenly stops working. And then I have to go and fix it. Sometimes it might be when it was designed, it could take care of most cases. We'll go deeper into that as I go forward. But there's some edge cases that come and trip whatever the designer had in mind. And I see a lot of times it's problems with data types. You're expecting numbers and somebody goes to type in his name while you're expecting numbers. That can break something you've built. So sometimes you have to think ahead, design in a robust way. But I'm just using that to tell you the importance of data types. Clean and prepare data for analysis. Every application, almost all, I think, have a data store of some sort behind it. Every application is collecting information and using this information to provide services for you, which is where as analysts, that's where we come in. So we're connecting into system. I'll say almost zero, but let me explain myself when I say almost zero. Your knowledge of, I don't want to use the word math because it's more arithmetic. Your knowledge of arithmetic will help you. Let me put it this way. And part of the things that I'm saying is that when you're approaching pretty much anything, you want to make sure you're very solid with the fundamentals. And the fundamentals of math not math, arithmetic. And I'm talking arithmetic is what you start to learn in grade 1, grade 2. I have a kid in grade 2. and I literally help him. I'm his lesson teacher. And it's so interesting that many things that I teach him with the application that he uses actually help me on my job. Because in the end, when a problem comes and I'm looking for a solution, very many times in the beginning of my career, I'm thinking about the most complex thing. And even I would see things other people have built and I'd be like, man, would I ever be able to get to this level? But now I know that when you give a complex solution for a simple problem, it's actually because you're not highly skilled. When you get highly skilled, your solutions actually become simpler. I'll give you an example. I was working for this company maybe about 6 years ago, and I had to build, that's what came to me. It was for an oil and gas company, and I had to build something that was tracking how they were moving products like crude oil through their pipes. I had to figure that out for them. And why did I have to figure out that for them? Because they move this with a lot of pressure. So sometimes they're using high pressure, sometimes they're using low pressure to move crude oil. And the pipes can last maybe 100 years. But if you're cycling it aggressively, which means high, low, high, low, high, low, a pipe that should last 100 years can end up lasting 20 years. And that's very expensive to lay new pipes. So they wanted to solve that problem. That's number one. And then number two, it could lead to an explosion. It could break, destroy a community and everything. So there's so many reasons why they needed to figure out at any point when any member of staff is cycling aggressively, so they could stop it. I built it. I built a solution. It worked. It's probably working now. It's still working. But it was very complex. It was so complex that even for me, it was scary. Because when you build anything, you're still going to keep getting requests. So they're going to want more features. Can you make it do this? Can you make it do this? But because it was so complex, to add the tiniest thing, to them it's simple. They're like, oh, this green, can you make it yellow? But I built something so complex that to make it yellow, I'm going to cause more problems just by adding that little thing there. So and your life just becomes horror, horror movie. Yeah, but now that same thing, which is why I was introducing Python in the beginning, I did it many years after, just on my own. And it was just about 7, 8 lines of Python code. Yet I had built this in all tricks and it was so complex. It was even scaring me, the designer. I can't even imagine who inherited that thing after me. I've inherited many people's crap as well. So to your question, is math needed? Not necessarily, but arithmetic is. So if anything, I would say, yeah, go back and clean up what you know about arithmetic. Like really go back to primary school math, which is arithmetic. Or the more of that you know, you would find out that you are not going in a roundabout way. Okay, think about it. What I built was so complex because I was literally reinventing the wheel. That's another thing I think I hope I will be able to get across to all of you in this course, is that my approach now as a senior person in this field is that realize that there's almost no problem, especially in technology, that doesn't have a solution. Meaning, any problem you're seeing and you're asked to solve, you aren't the first person to ever solve this. It's been solved. So I call it literature review. Like always go and seek. There's this problem, go research. There's solutions out there, and you just come back, deploy, and modify it for your own use case. But in my junior days, and as junior engineers, you just feel you know so much about coding. You feel you know so much about this tool, Tableau, everything, and you're just always literally creating problem. So again, to answer your question, do you need to know math? No, but arithmetic will help you. Look at the street lights. You see all the street lights. There's no human being controlling the street lights. It's software. But then if you just mention Python to someone, man, I don't like coding. But it's actually software that is controlling all the street lights. There's no human being. And this is happening all over the United States. And we don't have problems. We don't stay longer than we should stay. It turns green when it should, yellow, red for the most part. But think about it. I was shocked when I found out that to be able to do that, street lights all across the country, there might be maybe 1 billion of them. It's just lowest common multiple, LCM. This is something we did in primary school. So there might have been complex solutions before that, or they weren't able to do this until they just realized that, hey, and they used LCM, and that's how that thing works. And behind most of the most powerful solutions you're going to find, they're actually extremely simple, like your Google Maps. They're really simple. And when I moved to that approach, where I started going for literature review, as I call it, or best practices, you're looking for best practices, it means you're acknowledging, I have this problem. People have had this problem. How did they go about solving it? You will find different methods. And again, a more senior way to go about it is like, hey, what are the best solutions people have used for this? Your elevators in the hotel, think about it. you're in a 28-story hotel. I'm in floor 28 and I want to go downstairs. I press the elevator and it takes about 9 minutes for it to come for me. Nobody is going to stay in that hotel in the end. So there's already software that brings the elevators to anybody's floor in the quickest time possible. So if you went back to your village or my village and you wanted to build a hotel and you used the junior engineer approach, which we all do, you start to think about, how do I build software for this elevator? You're going to end up in systems like that. So anyway, I hope that answers your question. You will find almost all the solutions you need in arithmetic. You'll find out that a lot of those things that we were learning, they have a lot of practical application when you want to build software, because what we're doing with data analysis and Tableau developer, you're actually building software. Your role within the company is that you're a tiny software developer. What companies are trying to do is that, when you work with very large companies, you're going to find that a large company is not just going to buy a piece of software and accept the limitations of that software. And that's where you come in. So they hire us, they bring us in, and they make us push the software to the boundaries. They have their software engineers, they have their data analysts, we push everything to the software. Like I've gone to a company even and you find out even the way they use their Outlook, I'll get to a company like, I didn't even know Outlook could do this, but they continue to push. And that's what you find in large corporations. So that might be a long-winded answer, but no, you don't need math, but arithmetic will really help you a lot. So I perform basic exploratory data analysis. I consider myself a data professional now, and that's how I sell myself. Meaning I could do data analysis and but I've also done governance, I've done administration, I've deployed applications like Tableau and Alteryx for organizations. I've had to use Python extensively to push a software beyond its limit when I find the business needs something and the software cannot do it, and I bring Python. I'm saying this to tell you that, but these are all different roles. There's people that they're data engineers, there's data analysts, there's this new analytics engineer that is sitting in the middle of data analysts, and there's data visualization experts and data engineers, there's data science, and now we're seeing machine learning engineers, but one thing is that there's a lot of overlap. I'm saying that because you can see exploratory data analysis there. There's, to a certain extent, when you're doing things like Tableau, you would do things like that. But when you get into where they're trying to predict, of which a lot of companies are doing that right now. We see, for example, nobody's buying blue jeans in Montana. Why should Walmart put $3 million worth of inventory in Montana? So that's where you start to see where data is doing predictive work. So it would have cost us $3 million to stock Walmart with blue jeans. But why can't we take that $3 million and put it in another part of the company? Say, for example, California, there were more of that jeans. A lot of things that we're going to find here, you're going to see we're going to be step slightly into data science, we'll step slightly into data engineering. Like Mr. Festus introduced in the beginning, business analysts, you too, you're stepping slightly into data analysis. I think the world has changed so much that so much is expected from every individual that comes to work in any company now. The more reason why you just have to understand all of these things. You know when to go deep. It's really, in the end, when you get a task, you might want to deepen your knowledge heavily in one area, but that's that. So EDA is more in data science, but we dabble into it quite a little bit. And then interpret and communicate findings through data visualization. Yeah, because in the end, very many times, like, you're a type of doctor. It's really a very interesting thing, where it's almost like the way a doctor is going to look, you tell the doctor that this place is hurting you and everything, but the doctor with his training is looking at you with a different set of eyes and is trying to think skeleton or this or blood, but that's not the way you are thinking about the problem you have. But as you're communicating that, the doctor is using his advanced knowledge to try and pinpoint what you have. We have that relationship too, like I said, and that's real. It was one of the business leaders came across to our team, and they were like, yeah, sales is doing very well. They're making money. In fact, they had it was, how every company is supposed to grow by a certain percentage every year. We had good growth, but our costs were growing higher than normal. And one of the leaders came in and says, it had become a big pain for the CEO of the company, and they wanted to drive down. And in the end, we found what it was. We were managing over 10,000 drivers delivering food across the United States. And of course, that is very expensive if you multiply the cost of one driver per day and we had 10,000 of them wake up across the country and drive. And think about, we were paying them for, standard work day in the US is about 8 hours. Well, almost all of them were working for 12 hours for some reason, was what we found out. Now, if you multiply 4 hours by 10,000, that's 40,000. And let's work with something like $50. $50 times 40,000. I know my math might be funny. We're looking at about $2 million a day in losses because everybody's charging us over time. And then we went to find out what exactly is costing everybody to have to work extra 4 hours. We went in there, we found it, we solved it, we built a solution, and that 4 hours disappeared. Now, if you calculate $2 million for one whole year, that's almost $1 billion that we save. To be honest, that's how, when I interview, these are the things I talk about. I'm not going to be telling you how good I am with SQL, how good I am in Python, how good I am in Tableau. I know I can go in there and I can figure things out. Again, that's from the conceptual part of this, which I would want you all to have. I wish I knew this earlier too, but I didn't. Yeah, so that's that. But I just want this to be more introductory. I want you to have an idea of how this knowledge would add to your business analysis or whatever field you end up going into. So that has been my approach for today. But I'm going to make myself available to make sure you all get whatever you need to get out of this course. All right. Yeah, so data analysis is key concepts. Here on this slide, I have that it's the process of inspecting, cleansing, transforming, and modeling data to discover useful information, draw conclusions, support decision making. And another thing that has happened that has made data very valuable in the last few years is that technology, the tech for data. For a very long time, like I said, it was Excel, we had SSRS, we had SQL, but today we have tools like Tableau. And tools like Tableau are called low code, meaning we're coming from when only people that knew coding, software engineering, could do what we can now do today with Tableau. So you have to be like a software engineer to do the things you can do with Tableau. It just goes to show how the market is evolving. So even Alteryx is a low code. And there's many tools now, there's no code, where there's no code at all. Maybe an example is that Wix website that is always advertising. But if you look at a website like Amazon, I can guarantee you there's 30,000 software engineers that keep that website, every piece of it working the way it works for us. That's heavy code. For like the Amazon website or for like the Instagram that you use, I can guarantee you there's over 20,000 software engineers behind that. But then again, there's also low code and no code, and Tableau falls into a low code tool, meaning without code, you can do a lot in Tableau, but Tableau also has its own, I would call it expression language, which is a programming language of sorts. You don't have to use it, but if you use it, you can provide more solutions. You can solve more complex problems. And basically in this field, the more problems you can solve and the complexity of the problems you can solve is basically how much money you earn, because you're moving from company to company and they're asking you about what you know, what you've done. And when you're talking to them, you're telling them about things you've started, like, okay, yeah. So that's that. But yeah, it basically follows this process of where we're collecting data from different applications. And another thing I'll add to that is that the fact that that's where I was going with the tools. AWS, for instance, there's so many ways to store data now. Some of them are so cheap. In one of the companies I worked, I remember where the chief technology officer, gathered all of us in a room and he was having a talk to us. And he was talking, he really said this, and this is for a Fortune 50 company. He was talking about the fact that, hey, all companies generate a lot of data, but in the past, maybe just 4 or 5% of this data is handled, collected, cleaned, organized, and then they try and get insights from just that 4% of the data that they generate. But today, because of the technology is so advanced, no company is throwing any data away right now. By that, I mean the major place we go to, which we'll discuss in this course, which is why I brought SQL, is databases. But databases is structured data. But now there's all types of unstructured data, your tweets, your likes, all of those things. They're not typical data we've collected in the past, but now we need to collect them and we need to make decisions on this type of data. But now there's so many cool places to store them, and then we can connect them to all of these tools, and then we can draw insights. So it's a key part of this analysis process. So collect data from all type of places. Then we have to clean this data, which is where the tools like SQL and Alteryx will come in, put them into a shape, then start to draw insights that can help different parts of the business. So people come, see the dashboard you build, and then they can start making decisions. Oh, we need to cut down on this. Oh, should we do this? Oh, should we move into this area? Or should we stop doing this? Or this process that used to be 7 steps, we can drop this to 2 steps and stuff like that. And all of this just goes to save a lot of money for the corporations or make money. And again, I think in anything you do, especially when you work in a company, I hear it's good to be as close to the money as possible. Are you helping that company save money? Are you helping them make money? It could be very helpful to your career the closer you get to the money. That's that. We're going to go deeper when we discuss these tools and the concepts.